Okay, write down the coordinates where the point meets the curve, or meets the x-axis. Straightforward, that's where y equals 0. So we already have it factorised. X squared means just x minus 2 squared. Where that's equal to 0, and that's at x equal to 0, or x minus 2 is equal to 0. They're both the same, so that's x equals 2. So the coordinates of the point where the curve meets the x-axis is 0, 0, and 2, 0. Okay. Find the coordinates now of the turning points of the curve. Now we have to differentiate the curve. Let's multiply it out first. So you have x times x minus 2, x minus 2. And that is going to give you x times x squared minus 4x plus 4, which gives you x cubed minus 4x squared plus 4x. So the derivative of that, dy dx, is 3x squared minus 8x plus 4. Okay, and there we've got a quadratic. I'm going to clear just this top part so we can work it out up here. So to find the turning points, we put the derivative equal to 0. So you've got 3x squared minus 8x plus 4 is equal to 0. And that means we need two numbers that multiply to give you AC, which is 12, and adds to give you minus 8. And those two numbers are minus 6 and minus 2. And you split the middle term into those two numbers. So we'll put the minus 6x with the 3 and the minus 2x with the 4. Okay, and then if we draw a line down between the two sides, and we can factorise each side. So you'll have 3x, x minus 2, and minus 2, x minus 2 is equal to 0. And what's outside the brackets is your first term. So 3x minus 2 is one of your brackets, and then your bracket is the next term. So x minus 2 is equal to 0. So that means x is equal to 2/3, or x is equal to 2. Now, if you want to find the coordinates, again, I'll just take this bottom bit away. If you want to find the coordinates, you have to find the y value now. So the y value at x equals 2/3. Y is equal to 2/3 times 2/3 minus 2 all squared. Put it back in up here. Okay, and that's going to give you 32 over 27. So that's your first coordinate is 2/3, 32 over 27. And at x equal to 2, y is equal to 2 minus 2 squared, which is 0. So your other turning point is 2, 0. Okay. So using calculus, identify each turning point as a maximum or minimum. So I'm going to pause this and work out with both them turning points, which is a max and which is a min. Unpause for the solutions. Okay, we've got now the derivative was dy by dx was 3x squared minus 8x plus 4. So if we want to work out the second derivative, is d2y by dx squared is 6x minus 8, and that's the function for the second derivative. So at x equal to 2/3, at x equals to 2/3, d2y by dx squared is equal to 6 times 2/3 minus 8. 6 times 2 is 12, divided by 3 is 4, minus 8, which is minus 4, which is less than 0. So we have a maximum at the point where x is 2/3. And at x equal to 2, we've got d2y by dx squared is equal to 6 times 2 minus 8, which is 12 minus 8, which is 4, which is greater than 0, which is a minimum. So we know that the point 2/3, 27 over 32, wasn't it? Or 32 over 27. So 2/3, 32 over 27 is a maximum point, and 2/0 is a minimum point. Okay? So sketch the curve on the axis below. First, we know the points where it crosses the x-axis was 0 and 2. We go 2 there. We know the turning points were 2/3, 32 over 27. And 32 over 27. So 2/3 and 32 over 27 is roughly 1.18. So roughly we go there. And the minimum point was at 2/0. Okay? So we know that the curve, the cubic curve, comes up like this to the maximum point. Now the minimum point is 2/0. Because it's a repeated route, it hits at it and goes back up. It cuts through on a cubic graph. It cuts through the point if it's represented singularly. So you have x, x minus 2, x minus 2, and if you've got a repeated, it touches. So it hits it twice, coming down and coming back up. Okay, and that's your curve. Okay, and this last one, I want you to just pause and work through the first 2 points in the same way and unpause for the solution. So write down the coordinates where the curve crosses the x-axis. Simply put y equal to 0. So you have x plus 3, x minus 4 equals 0. So that's x is equal to minus 3 and x is equal to 4. Okay, so the coordinates is when x is equal to minus 3, y is equal to, putting it back in here, y is equal to 0. And when x is equal to minus 4, putting it back into the top, y is equal to 0 as well. And of course, because it's where it cuts the x-axis. So y has to be 0. Find the coordinates of your turning point. So again, if we differentiate our curve, well, first of all, we multiply it out. We get x squared minus 4x plus 3x minus 12. So that's x squared minus x minus 12. Now the derivative, dy by dx, is equal to 2x minus 1. So at the point, minus at x equal to minus 3, we will find, no, we don't do that. At x equals 3, we're finding the turning points, sorry. There are the points were across the axis, we're finding the turning points. So we put that equal to 0. So 2x minus 1 is equal to 0. So x is equal to a half. Okay, and the turning point is a half. So to find the y value when x is equal to half, we sub it back into the top. So y is equal to a half plus 3 and a half minus 4, which is 3.5 times 3.5, which is minus 12.25. So that's our turning point. It's 0.5 minus 12.25. Okay. Again, pause and find, is that turning point a maximum or minimum? Okay. We know that dy by dx is equal to 2x minus 1. So d2y by dx squared is equal to 2, which is greater than 0, which is a minimum. So we know that the point 0.5 minus 12.25 is a minimum point. Okay, and sketch the curve. Again, if you want to pause it and try and sketch it, and then unpause and I'll show you the sketch. So we know it cuts the axis at minus 3 and 4. So at minus 3 and 4, we know its minimum point, turning point is 0.5 minus 12.5. So 0.5 minus 12.5. Minus 12.5, or 2.5, sorry. And the curve goes down like this. And that's meant to cut through at that, or ahead at that point. Okay? So the turning points differentiate and put equal to 0. And all the questions are the same. So get used to differentiating and then doing the second derivative. And if it's greater than 0, in the second derivative, it's a minimum. And if it's less than 0, it's a maximum.